You may already know that every access control system has three basic parts: the reader, the controller, and the lock, or locking device. In a networked system, they are connected to each other, for each part must send information to the other in order to unlock doors, sound alarms, and so on. At first, all the connections were done with wires. This is known as hard wiring. Today, there are many devices that can communicate wirelessly, which can make installation much easier since wires don't need to be run all the way to the door or through the door. Administrators and occupants can have a more seamless access experience too, being able to use and manage the system with their phones. Let's explore a few different wireless technologies used in access control today and learn how each has its own advantages and limitations. All wireless technologies basically do the same thing: send information from one place to another over the air. What makes them different is how much information they can send at a time, how far that information can travel over the air, and how much power is needed to send it. One of the earliest technologies that is still around today is known as 900 megahertz. What that term actually means, 900 and megahertz, isn't as important as knowing how much data it can send, how far, and how much power it uses. It doesn't send a lot of information at a time compared to newer technologies, but it can send it quite far, up to 1,000 feet, and it doesn't use very much power. It is often still used in building systems that don't transmit large amounts of data, which makes it great for access control, since it's usually only small card ID numbers and small commands to lock and unlock that are transmitted. Something happened in the early 21st century though. People started wanting to send very large amounts of data, like photos, videos, and music, wirelessly. A new technology called Wi-Fi was developed, and now it's one of the most commonly used wireless technologies today. It's found in smartphones, cameras, televisions, and an increasingly large number of home appliances. Wi-Fi devices connect to an access point. You might hear it referred to as a hub or a router, and use it to send and receive data. Wi-Fi can transmit a large amount of information over a much shorter distance than 900 megahertz, up to 150 feet, and requires a lot of power. It takes more power to send more data at a time. Wi-Fi is appropriate for access control devices like video surveillance cameras that may have large amounts of high-definition video to send to the system. With this amount of data, a lot of power is required. The camera may send information over Wi-Fi, but gets its power from a hardwired power supply. Your smartphone or notebook computer have batteries, but they may only last 1 or 2 days before you need to recharge them. So if you had an electronic lock or card reader that used Wi-Fi, would you want it to run on batteries or line power? If you chose batteries, you may be replacing them more often than you'd like. And if you chose line power, you need to run the electrical wire. If only there were another wireless technology that didn't use so much power. Enter Bluetooth. Bluetooth was originally designed to be a kind of personal area network, meaning it was a network for things near you. No access point is needed. Devices can connect directly to each other. If you've ever used a wireless headset with your mobile phone, it was probably using Bluetooth. A version of Bluetooth, called Bluetooth Low Energy, or BLE, uses very little power compared to Wi-Fi, but can't send as much information at a time, nor as far. It's a great solution for electronic locks since they don't need to send information very often, and when they do, it's a very small amount. BLE devices require fewer battery changes, and no wires need to be run to the door. BLE isn't the same as Wi-Fi though. The signals are not compatible, so a BLE device needs a different access point to connect to a network. There are two other wireless technologies you may hear about, Zigbee and Z-Wave. They are both extremely low power. Devices can run for years on a small coin cell or watch battery, but have corresponding very short ranges and small data transfer. You'll see them used in some residential locks, thermostats, or light switches, devices whose operation is mainly on and off, or open and close. As you can see, these wireless technologies were designed for certain needs, and there isn't one wireless answer for every situation. Wi-Fi, BLE, Z-Wave, and Zigbee aren't compatible with one another either, so manufacturers have to decide what technology best supports their solution. This can be why you often see products at the store featuring the technology they support. Customers may want to know if the wireless technology is compatible with other products they're using. Now that you know the forces that shape each wireless technology, data size, range, and power requirement, you might now be thinking, how great would it be if one of these low-power technologies could have a bigger range? There isn't a wireless technology answer for that question yet, but there is a type of networking technology that shows promise. It's called a mesh network, where instead of every device connecting to an access point, they can connect to each other to send information. And so if one is far away from an access point, it can use the devices in between to get there. So, a lock that is too far away from an access point may only need to send its information to a nearby lock, eliminating the need to install and set up an additional access point. Not all wireless devices support this kind of networking, but it is a term you may hear more in the future. In fact, Z-Wave is a mesh network, so that all the wireless devices in a home can communicate through each other rather than needing multiple access points. It's common to find more than one wireless technology in a building, part of an access control system using Wi-Fi, like a video camera, and another part using BLE, like a lock, can be an appropriate way to solve needs and provide the right balance of benefits and maintenance. Let's look at all of these technologies in a chart to compare and summarize them. If you haven't seen it, check out the video, Intro to Access Control, Wired Communication Technologies. The understanding of these technologies will help you as you advance your work in access control.